going to go over some notes. Pythagorean theorem. But this time we're using it in a little different way. So today is the 26th. It could be the 27th or 28th. I'm recording it for future classes as well. So if you remember, Pythagorean theorem, PT, is a squared plus b squared equals c squared. Now, some of the first few problems are just, they're just basic skill set. And then we're going to apply it to other shapes, okay, that aren't maybe triangles. So if we have PT is only used for right triangles. The legs are A and B, or B and A, and the hypotenuse is C. So if I tell you that, excuse me, this is 9, this is 15, and we want to find B. So we would plug this into the formula, and we would get 9 squared plus B squared equals 15 squared. 9. And then we would continue to solve. So 9 squared, 81, plus B squared is equal to 225. And then subtracting 81 on both sides. Get B squared is equal to 144. Anybody remember the opposite of a square is what?
A square root.
Good. We're going to square root both sides. And we get B equals 12. Okay, so we've done that. That's nothing new to us. But today we're going to be looking at it in a slightly different fashion. So what if I have this trapezoid? It's like a swing set. And we're told that these are right angles. This is 5. This is 5. This is 10. And this is 16. And I want to find X. So the first thing we want to do is locate in our picture the triangle to solve. Now that's going to look different for each problem. In this case, so in this case, it's going to look like this triangle. This is 5, this is X. But according to the 16, how big is that? How do we know? What do we know?
It's 6.
Okay, it looks like 6. And I think you're getting that from taking the 10 from the 16. Is that right?
Yes.
That's the first step. But remember, there's 2 sides to our triangle. So what do we do with that 6?
We divide it by 2.
Perfect. Divide it by 2. So this is 10. That means this part and that part have to be the 6. So these would each be 3. So that would be 3. Okay. And there's the triangle that we need to solve. So using our Pythagorean theorem, we have 3 squared plus x squared equals 5 squared. And many of you already know what that number is going to be, but we'll go ahead and solve it. The 9 plus x squared equals 25. And subtracting 9 on both sides, x squared equals 16. So x is what? Anybody? Square root of 16 is
4.
4. Nice. And there's your x. So we're using Pythagorean theorem, but we're using it a slightly different way. Okay. And sometimes we have to do a 2-step process in order to find our answer. So okay, we'll come back to that one. I'm going to go back for just a second. I'm going to look at this triangle. And the only reason I'm doing this is because it has a radical in it, where I can say this side is 5 and this side is 5 root 2. And we want to find x. It's still the same formula, where our hypotenuse is that side. Sorry about the shadow on the paper. So I have 5 squared plus x squared is equal to 5 root 2 squared. And please put that in parentheses, because that square affects both parts. Okay. So multiplying out, we get 25 plus x squared is equal to. Now, when you're doing exponents, we're going to square the 5 and we're going to square the root 2. So this becomes 5 squared and root 2 squared. 5 squared is 25 and root 2 squared is 2. This becomes 25 plus x squared equals 50. This is the part that, I mean, you may know how to do the Pythagorean theorem perfectly, but this might be the part that'll trip you up. Okay, so minus 25 on both sides. X squared equals 25. And then taking the square root of both sides, you get x equals 5. And you probably already knew that if you recognize the pattern. It's one of our special triangles. Okay. So any questions on that?
What happened to the 2 root or the root 2?
When I squared it, they square and the square root, they cancel each other. Or it becomes root 2 times root 2, which if you want to call root 4, which equals 2.
Yeah, I remember. I just kind of forgot for a second.
No, I'm glad you asked. Thank you. Okay. So any other questions I can answer? Okay. Well, let's dive right into the assignment then. page 292. That's the first part. There are a couple I'm gonna let you do. Let's start with number 4. So if we have time, we'll go back and do 1 through 3, but I'm gonna have you do those on your own if we don't have enough time. So number 4. 9, 11, and x. Which one's my hypotenuse?
11.
11. Good. Your hypotenuse doesn't always have to be a number. It can be a variable. So we have 9 squared plus x squared equals 11 squared. So 81 plus x squared equals 121. And then subtracting 81 on both sides, x squared equals 40. And this becomes just a practice of square roots. So x is equal to, we need to break that down. I can do 4 times 10. The 10 is 5 times 2. The square root of 4 is 2 with a leftover 10. So all of your answers should be left in radical form, no decimals. No decimals. I'm going to have you do number 5 and put the answer in the chat box. 10, 20, and x. Okay, go ahead and work it out and put your answer in the chat box. Good. Let me give you a minute to do that. Work through that. Okay, so 100, so 10 squared is 100, plus x squared equals 400. Subtracting 100 on both sides. X squared equals 300. And square rooting both sides. X is equal to, I'm going to call that 3 times 100. And then the square root of 100 is 10. So x is equal to 10 root 3. Good. Let's do number 7. For time's sake, so the ones that are basic skill, I'm gonna maybe let you do most of those because they're just, use a calculator. It's fine. But number 7, there's a right angle. This is 4 root 3 and x. Which one's my hypotenuse now? Which one's my hypotenuse?
X.
X, good. So this time, X is my hypotenuse. So I'm gonna do 4 squared plus, here's the tricky part, 4 root 3 squared is equal to X squared. So 4 squared is 16 plus, remember that our square goes to both of these. So 4 squared is 16 and root 3 squared is just 3. So we've got 16 plus 48 is equal to X squared. 16 and 48 make 64. And the square root of 64 is what?
Eight.
Good. And you're done. So notice when we square a radical, we're squaring the integer in front. And then when we square the other part, it's just the number underneath the radical. Okay. All right, I'm going to jump over to the second part of the assignment because it could be a little bit more challenging. Let's look at number 22. It says that this is a right angle. This is 6 and these are 8. And they want to know, what is this whole side? Remember, I'm not doing this for myself. We're doing this together. So what do you guys should have already drawn the pictures. What is the triangle or that I'm trying to isolate in order to solve this problem? Anybody unmute yourself and tell us?
You mean like a general term for the triangle?
Well, what I mean is, am I looking at the big triangle like 8, 8, and X? Or am I looking at one of the triangles and then using that to get my X? I think that's what I'm asking.
Probably one of the triangles.
Okay, absolutely. I really, unless I have a right triangle, I cannot use Pythagorean theorem. So trying to find X from 8 and 8 and X is not going to work because I don't know that that's a right angle. It's not actually. Okay, so I've got to use one of these triangles in order to find my X. So I need to find this part first because we know that they're two identical triangles. So this is what I call isolating or identifying my triangle, which would be this one. Okay. So 8 would be my hypotenuse. Actually, I'm going to do it this way, just so you can see it. But this is 6, X, and 8. That's the triangle that I'm isolating. So let me call that Y, actually. I don't want to get it confused with my other X. Okay, so I've got 6 squared plus Y squared equals 8 squared. Okay. So go ahead and solve that. Put your answer in the chat box. What do you get for Y? So we've solved for this one part of our triangle, but that corresponds to this right here. This is 2 root 7. What does that make this other part over there?
2 root 7.
Also 2 root 7, because they were identical. So in order to find x, x is equal to 2 of those, or 2 root 7 plus 2 root 7. And remember, when we add those together, we're adding only the integers, so we have 4 root 7. Questions on that? Did that help? Those of you that said, I don't know.
Yeah, a lot more.
Good. Good. A couple other people said that helped also. Okay. Good.
Wait, I have a question. I think I missed a step. How'd you get 4 root 7? Like, wouldn't it be 2 root 14?
Oh, when we add radicals, the radicals become like a variable. They have to be the same radical in order to add or subtract the numbers in front. So it's kind of like a 2x plus 2x will give us a 4x. So
Okay.
yeah, is that better?
Yeah, thank you.
You bet. Okay, so that was 22. 23. These are similar to the problem that we did in our notes. So go ahead and look back at your notes. Kind of our swing set problem, where the hypotenuse are 13. This is 11. This is 21. And we want to find x. Okay. So the first thing we need to do is isolate or identify the triangle that we need to solve for x. Zero x. If that's x, then that's the triangle I need to solve. So I need to be able to find this leg down there. Any ideas?
Subtract 21 and 11,
Okay.
and then divide that number by 2.
Perfect. Okay. So since this is 11, we know that 10 has to go for each side, or for the total of both sides. So we have 10 left over divided by 2, and that gives us 5. So identifying the triangle that we need to solve for x, 13 and 5. So go ahead and solve for x and put it in the chat box. So some of you are on the right track, but some wrong numbers. Okay, so this is my c, that's my hypotenuse, because it's opposite the right angle. So x squared plus 5 squared equals 13 squared. X squared plus 25 is equal to 169. And then if we subtract 25 on both sides, okay, so we get x squared is equal to 144. I think some of you tried to make x your hypotenuse, and those being your two legs, but the hypotenuse is always opposite the one from the right angle. So square rooting both sides, the square root of 144 is 12. So if you didn't get the answer of 12, can you tell me in the chat box that you got it now?
I have a question. Why, because I did get 12, but wouldn't you also put a square root over the 12? Or no?
No, because what you did is the square root of 144 is 12. So 12 is the answer to the problem.
Okay, because it goes in evenly.
Yes, exactly.
Okay.
Thank you for phrasing it like that. I think more people needed to hear it that way. Good. And I love the answer of I overcomplicated it because I do that so much. I always try to make things harder. So thank you for that. 24. This is an upside down swing set. It's our trapezoid, and it's an isosceles trapezoid. You remember isosceles means two equal legs?
Was 12 the only answer on problem number 23? Was that the only thing we needed to find?
Mhm.
Okay.
Because it was the height, and the height was the same for both triangles. Now on number 24, though, it's a little more involved because now we're looking for the whole thing. This is 10, 12, 12, 15. Okay. So when we look at the triangle that we need in order to solve for x, it would be that one. I'm gonna dial it again over here. I need this one. So I have to find that length in order to be able to solve for x. So that's the triangle that we need to identify and solve in order to solve for x. I'm going to call this y. So which one's my hypotenuse?
Is it 15?
It is. Good. Okay. So I'm going to have you guys solve for y and put it in the chat box, but solve for y and then solve for x. Let's see how you guys do. So 12 squared plus y squared equals 15 squared. And 15 squared is 225, in case you didn't remember. Solving for y. So 144 plus y squared, subtracting 144, y squared equals 81. Okay, so everybody had the y. Y equals 9. That was perfect. Okay. So if y is 9, that makes this 9. That's why drawing the picture is so important, because, and then this is 9, which, yes, that is 18, which some of you got, but we have to include this piece in the middle, which is how big?
10.
Okay, so now x is the whole thing across. So it's 9 and 9, which makes the 18 plus the 10. So x is equal to 28. Okay. But so some of you were super close. You, I could tell you were just missing the 10 that was in the middle. Okay, good. There's 24. Let's get 25. Okay. So 5, 8, x, and 11. This is a little tricky because I don't see a triangle. All the other problems, I've had a triangle. So my question to you that I would ask is, can you find a triangle to separate out of that problem? What do you think? How would I do that? can I think of making it two figures in one?
You would cut off make the 11 and the X, like put a line down through to make that a triangle.
Nice. So he's saying I can put a line down here and make a triangle. That's perfect. Okay, so that would now be a right angle. So how big would this bottom part be over here?
5.
5. So how big would this part be left over?
6.
6. Okay. And then how tall is this triangle?
8.
8. Nice. We just separated this into a rectangle and a triangle.
How did you get 6?
Okay. Because I knew that this top part was 5. So if this is 5 and the whole thing is 11, I'm going to subtract the 2 and get 6.
Okay.
Good. So there's the triangle that I've been able to isolate in order to find X. So I've got 6, 8, and X. Go ahead and solve for X. Put it in the chat box. Nice. Alexander's got it. Okay, good. A lot of people got it. So we have, this becomes my C, my X is C. So 8 squared plus 6 squared equals X squared. 64 plus 36 is equal to X squared. So if you add these two together, we get 100 equals X squared. And then square rooting both sides, I get 10 equals X. So if you didn't get it before, can you let me know now that you understand it? You say got it or yep. Okay, good. Nice. Awesome. Okay. 26. We're almost done with this part. I've totally lost track of my time too. Sorry. Okay, so 26, let me write that down. This is another one that we have to isolate our triangle, very similar to the one we just did. Okay. So many times, like the last one, we're going to break it into a rectangle and a triangle. So go ahead and draw your rectangle and triangle, and let's identify the parts that we need. I'm going to give you a second to do that. Okay, so anybody share? How did you break it apart? Some of you are really visual, so this is a good thing.
12 and 10 and put the line through, like, you know what I'm saying?
Vertically or horizontally? Side to side or up and down?
Horizontal,
Horizontal.
like straight across.
Yeah, straight across. So this would be my straight across. Okay. So now, how big is this inside part right there?
Six.
Good, thank you. This is 6. So how big is this up there on that part?
4.
Good. Because I subtract the 2, subtracting the 6 from the 10, I get 4. So now this part that I can like move up is my x. So I've just isolated the triangle, or identified it rather. It's 4x and 12. Okay. So go ahead and solve that for x and put your answer in the chat box. Put your answer in the chat box. Okay, so many of you got it. Some of you are really close. So remember that this is C, opposite my right angle. So 4 squared plus x squared equals 12 squared. So 16 plus x squared equals 144. And then because my x is on the left side, I've got to subtract the 16 over. X squared is equal to 128. Okay, and then we square root both sides. But when we take the square root of that, we can break it down to 64 times 2. There's a lot of different ways you could have seen that. But anybody, what's the square root of 64?
8.
So that's the one that goes outside, and then your leftover stays inside. So 8 root 2. And then 27 is the last one we're going to do for today. And the rest I'm going to let you do, because they're just calculator problems. Once you understand the concept, good. Okay, so number 27. This is what I call a two-step problem. And 6, 15. Thank you, Gabriel, for letting me know. Yeah. And okay. So if I want to isolate my triangle to find x, it would look like that. But I can't find x until I know this other leg, because I would have to have something squared plus 15 squared equals x squared. So let's call this y, because we can. Alexander, I do think you're correct. Thank you. Good. Let me go ahead. Okay, so if I need to find y, I can use this other triangle. So this is a two-step process where I have to actually find y first before I can find x. So let's go ahead and find y first. So it's 10, 6, and y. So go ahead and find y. And then we're going to turn around and find x. So use that to find y, and then find x. So solving for y, c is my is 10. So y squared plus 6 squared equals 10 squared. the y squared plus 36 equals 100. And then subtracting 36 on both sides, y squared equals 64. And the square root of 64 is 8. And a lot of you told me that in the chat box. Okay, so now I know that y equals 8. So now that I know y, I can find x. Okay, so now I know that this is 8, 15, and I can find x. And remember that x has to be bigger than either of these two. So x is going to have to be bigger than 15. We already know that much. And C is my hypotenuse. Good. So if you got the 289, you need to take the square root of that. And you might not recognize it. You might need a calculator. Okay. So this would give me 8 squared plus 15 squared equals x squared. So 64 plus 225 is equal to x squared. And adding these together, we get 289 equal to x squared. And when we put this in the calculator, the square root of 289, there's only one number for it. It doesn't even break down. Good. 17. X. So if you're using a calculator and you got like 17.2, then you would want to break it down using square roots, if possible. Okay. It could be like the square root of 290. I don't think anything goes in there with doubles. So you would have just left it as a square root of 290. But if you put it in the calculator and it's 17, then you know you're done. So this is what I call a two-step triangle, because we had to use one triangle to find one leg in order to find the other part that was our answer. Okay. Any questions on that?